This is R.D. Sharma solution, class 12, chapter 11. Differentiation, we are taking exercise 11.4. Now, if we have a cos y equals x cos a plus y, cos a cannot be equal to plus minus 1. We have to prove that dy by dx is equal to cos square a plus y by sin a. So we have seen a question like this where we don't have any x on the right hand side. So this x has to be substituted from the question being given. From this equation, if you compute x will be cos y. I am bringing this cos a plus y in the denominator. So this is going to be your x. Alright. And this sometime at some step we are going to substitute. Let us go to the normal way in we were solving. How we were solving? The left hand side, right hand side, left dy by dx, right other things. So cos y differentiation is minus sin y and then y is dy by dx. So x cos, right hand side x cos a plus y. So we'll use the product rule. X dy by dx of cos a plus y, then plus cos a plus y and d by dx of x, which is going to be 1. d by dx of x is 1. Okay. So we have x and d by dx of cos a plus y is minus sin a plus y. And since we have a plus y also, so we have to take the differentiation of a plus y also. A is 0 because it is a constant and y will be dy by dx. So this is going to be minus sin a plus y into dy by dx. So whole will be minus x sin a plus y and dy by dx. And this cos will be cos a plus y and because cos a plus y we have already done the product rule. So minus sin dy by dx, so we will just combine this dy by dx together on one side. So when I take dy by dx on left hand side, just assume that we have this term already on the left hand side. So it will become positive and this will become is equal to. So in one step only I am trying to explain. Alright. X sin a plus y, and from here it will be sin minus it was, so negative sin y. So we have x sin a plus y minus y on the left hand side with dy by dx. On right hand side we have this cos a plus y. Okay. Now this dy by dx we are going to put this on the denominator, but still we have x. And when I started doing this question, I already told you that this x will replace. So cos a plus y will be on the right hand side, and this term which we are going to put in the denominator, I am replacing x by cos y by cos a plus y. So this is cos y by cos a plus y, and now this is sin a plus y and this is minus sin y. I am doing this term, then we'll take it to the denominator. So let us take the LCM here. LCM is, you multiply the cross with the negative and divide by the multiplication of the denominator. So cos y sin a plus y minus sin y into cos a plus y and divided by cos a plus y. Now this cos a plus y is in the denominator and this will go in the denominator, remember? So this cos a plus y, when we'll bring it in the denominator of the denominator, it is going to go to the numerator. Just assume that the numerator is p and denominator is q. So p by q, when we'll put, q will go in the numerator and q is of course cos a plus y only. So cos a plus y into cos a plus y will be cos square a plus y. Now we just have to deal with p. P is what? If I write it as sin a plus y cos y minus cos a plus y sin y. So this is sin a cos b minus cos a sin b. It's sin a minus b. Sin a plus y minus y, so y gets cancelled. You have a sin a in the denominator. So just put it here, sin a. So we have to prove, or we have proved dy by dx is this. Now we have if sin square y plus cos xy is equal to k, find dy by dx at x is equal to 1 and y is equal to pi by 4. We will do the differentiation and we'll put y as pi by 4 and x equals to 1. There is one more question coming, so just watch this question very carefully because I'm going to leave that for you. Alright. So this sin squared y will be 2 sin y. Then the differentiation of sin y, which is going to be cos y, and differentiation of y is dy by dx. Next one is cos xy. Cos xy differentiation is minus sin xy. Then the differentiation of xy will be x dy by dx plus y d by dx of x, which is going to be 1. I am not writing it. So it will be sin xy into x dy by dx plus y. And this is equal to k. Differentiation of k is going to be constant. It is going to be 0. Now let us combine this dy by dx together. So you have 2 sin y cos y dy by dx minus sin xy, x sin xy. I am multiplying it and xy dy by dx. And then minus y sin xy. This is going to be equal to 0. Now just combine this dy by dx and then find out the term 2 sin y cos y. So this 2 sin theta cos theta, actually it is 2 sin theta cos theta. So you can directly write it as sin 2 theta. Okay. So 2 sin y cos y is sin 2y. So I am writing it as sin 2y. Minus x sin xy. dy by dx I have already taken common. And bringing or transporting this on the right hand side, y sin xy. Now we can bring this down in the denominator, cross multiplication you can say. So this is sin 2y minus x sin xy in the denominator. So now we'll put x as 1 and y is equal to pi by 4. X is 1, so wherever x is there you can just eliminate it. It's 1 only. Y will be pi by 4, so it is pi by 4 sin x is going to be 1, y is pi by 4. So sin pi by 4. And sin, it's 45 degree. Sin twice of y, 2 into 45 is 90 degrees. So sin pi by 2 it is. So this is going to be sin 90. So let me write it as, this is sin 90. So I'm writing it as 1, sin 90 is 1. And minus x is 1, sin xy. So sin 1 sin 1 into pi by 4. Again sin pi by 4 is what? It's 1 by root 2. So write it as 1 by root 2. So pi by 4 is already there. Sin pi by 4 is 1 by root 2. So pi by 1, this pi by 4 into 1 by root 2, 1 by 1 minus root 2. So take the LCM in the denominator. 1 by root 2, it is going to be root 2 minus 1 by root 2. So you can just cancel this root 2. So it will be finally pi by 4, 1 by under root 2 minus 1. Or if you just want to write it the way the book has provided the answer, it's pi by 4 into under root 2 minus 1. Y is equal to log cos x sin x log sin cos x inverse plus sin inverse 2x by 1 plus x square. And we have to find out dy by dx at x equal to pi by 4. So as I was discussing, this I am going to leave for you only the final step. The basic step I am going to do. That is, I am going to differentiate it properly. We'll do the differentiation and then whatever substitution is required, which is x equals to pi by 4, that will do. So let us see. This is all log. You have to have the knowledge of the logarithmic properties. Then you will be able to solve this properly. So log, if the base is say x and it is y, log base x y. So you can write if it is minus 1, if it is the power y minus 1, this x and y can change the position. It is log x with the base y. So log cos and sine, I'm writing it in short. So log base cos sine, and since we have this as inverse, we can just write it as log cos and sine will change the position, so it will be cos and sine. So they both are same, log cos x sin x, both are log cos x sin x. Base is cos x and we have sin x, so it is square of it. Now we cannot differentiate it now because the base is still something else. You have to convert this base into e. So log xy is log y by log x when the base will become e. So this log base cos and sine can be written as log sin x divided by log cos x. Now the base is e. Now we can start the differentiation. So basically it is square. Okay. Now let us differentiate the first part. Sin inverse 2x by 1 plus x square will take just now. First complete this one. So what is the differentiation? Anything with any power is, we consider is to be x to the power n, like x to the power n kind of thing. So x to the power n is n x to the power n minus 1. So this is going to be equal to twice of, just assume it to be p. I'm not going to write it again just to save the time and place. So if it is p, it is twice p. And d by dx of this p. This whole one. So if I have to do the differentiation of this is to be done using the quotient rule. It is a by b. A is log sin x, log cos x. If we assume it to be some p, which is actually a by b, we have to do it by the quotient rule. P is all of this. So I am going to differentiate it and then I am going to write it. So what is in the denominator? Log cos x whole square. This is your denominator. Log cos x will come here, and then differentiation of log sin x. Then subtraction minus log sin x and the d by dx of log cos x. Okay. So log cos x will remain like this, log cos x, and log sin x. Differentiation of log is 1 by that thing. So it will be 1 by sin x, and sin x differentiation is cos x. It is going to be cos x. Now minus log sin x. Let us write it like this. And I am not writing the denominator now, doing the numerator only. So d by dx of log cos x is 1 by cos x is minus sin x. So I am writing sin x here and changing the sign, negative to plus. So what it will be? Cos by sine and sin by cos. Cos by sine is cot, sin by cos is tan. So we have cot x log x plus this is tan x, so tan x log sin x. So what is up front? You have twice of p. P is what? I told you. It is log sin x by log cos x. So when we write this log sin x by log cos x, and if you remember, we have the denominator already. I didn't write the denominator just now. I am writing it because the denominator is log cos x whole square. So we have a log cos x square when we have log cos x also already there. So it will be q. So log cos x, this is the whole differentiation. This is the first part. We have already done the first part. That is the first term differentiation done. Now the second is sin inverse 2x divided by 1 plus x squared differentiation. So this is going to be 1 by under root, whatever the content is there, and 1 by under root 1 minus square of that thing. So 1 by under root 1 minus 2x by 1 plus x whole square. Now differentiation of this internal term 2x by 1 plus x square. Okay. So this, let me just do it first. Then we'll do the differentiation here. So this is going to be, see, it is basically 1 minus 4x square by 1 plus x square. So let me write it here, 1 by under root 1 plus x whole square minus, or first let us square it. 1 minus 4x square by 1 plus x square. Now this is going to be 1 plus x, 1 by under root 1 plus x square and minus 4x square divided by under root 1 plus x square. And since it is in the under root and it is in the denominator, it will go up. So under root 1 plus x square whole square. So this will go in the numerator, and square, because it is square inside the under root, it will also get cancelled out. So what is the denominator? See, 1 plus x square is the numerator now. So whatever it is, this is nothing but this is 1 plus x square minus 2x whole square. So when you open it, you will get a formula. This is nothing but, I'll just show you. This is simple thing, 1 plus x, and this is not yet being solved because we just have to do 2x by 1 plus x square also. This we are going to do. So I'll just do this one and then I'll write the answer. So 1 plus x square divided by under root 1 plus x square minus 4x square. This is clear. Now differentiation of this is going to be 1 plus x square whole square in the denominator, 1 plus x square, then differentiation of twice of x will be 2 only, minus 2x will come in front, and differentiation of 1 plus x square will be 2x. So it is 2x. What did we get? It's twice of 1 plus x square minus 4x square. So there is a short of space I am having. So 2 plus 2x square minus 4x square, you get 2 minus 2x square, and 1 plus x square is already there in the denominator, 1 plus x square whole square, 1 plus x square whole square. So 1 minus x square by 1 plus x square, and what was there? 1 plus x square by 1 plus x square whole square. See, this is all 1 plus x square, and you can just change it, right? So under root, when you solve it, 1 plus x whole square minus 4x square, this is nothing but 1 minus x square whole square. This is nothing but this one only, 1 minus x square whole square. So since it is in the under root, only 1 minus x square will come. So 1 minus x square it is. So 1 minus x square gets cancelled. 1 plus x, one of the 1 plus x square whole square, one of these will cancel. So final will be only twice 2 by 1 plus x square. So this is the final result. So this is the final solution for the sine inverse 2x by 1 plus x square. So this one is the first solution. Let me remove it. I hope the differentiation is clear to you. So this is the final thing I have written. This we already got. So now, as the previous question we have done, which has just have to replace wherever x is this by pi by 4. Remember, pi by 4 is 45 degree. Sin 45, cos 45 is 1 by root 2, and tan 45 and cot 45 is 1. So this is the time I am leaving this question, because I hope you'll be able to do it. The basic idea is to differentiate, which we have already done. Let me reiterate. Sin pi by 4, cos pi by 4 is 1 by root 2, and tan pi by 4 is 1. Okay. So this I hope you will be able to solve after this. This is your final. Just for your reference I have given. You can just match your result with this after you put x as pi by 4. Next one is this one. Under root y plus x plus under root y minus x is equal to c constant. Show that this dy by dx is y by x minus under root y square by x square minus 1. So we'll do the differentiation, and see, under root of anything, for example, under root of p is 1 by twice of under root p, and differentiation p then. So 1 under root y plus x is 1 by twice of under root y plus x, And y plus x differentiation is what? Y plus x. This is going to be the differentiation. X is 1 and y is dy by dx. So second one, under root y minus x is 1 by twice of under root y minus x. Y is dy by dx and differentiation of x is 1. And this is equal to the constant. Constant is differentiation is 0. Okay, now multiply this. And then we'll take dy by dx on one side and others on other side. Now I just visualize and imagine that I've already multiplied this inside and I'm taking common dy by dx. So when we take dy by dx here, 1 by twice of under root y plus x will come. This one, when you multiply with dy by dx and take dy by dx common, what will be the result? 1 by twice of under root y minus x. What will be remaining? Already dy by dx is done, so multiplication of this with 1. And I'm taking it on the right hand side also, and in the same step. Same step. So this will be the first one will be negative when we take on the right hand side. So minus 1 by twice y under root y plus x. And this one, this is negative. So when it goes on the right hand side, it will be positive. So 1 by twice of under root y minus x. First we have to multiply and then take it on the right hand side. So 1 by twice of under root y minus x it will be. Now dy by dx and this. Are we able to resolve certain thing, cancel something? Yes. First thing is 2 in the denominator is everywhere seen. So you can just cancel these out. You can just take 2 common from both the sides and it will be a normal cancellation. Now I'm taking the LCM here. Here also both sides I'm taking. So simple under root y minus x plus under root y plus x divided by under root y plus x into under root y minus x. Dy by dx is already there. What this will be? Under root y plus x minus under root y minus x divided by again under root y plus x into under root y minus x. This is clear? Now what do you see here? In the denominator, the terms are same. Denominator terms are same. So you can just cancel these 2 out. You can remove this because they are same. And now only the numerator of the left hand side remains, that can go in the denominator on the right hand side. So under root y plus x minus under root y minus x divided by under root y minus x plus under root y plus x. So we will rationalize it now. What is the rationalization? We always want the denominator to get resolved. So we have under root y. Since we have y plus x in the y plus x here, we can just change the position because plus, when it is plus, it doesn't matter. So we can just write it here as under root y plus x minus under root y minus x. Here also y plus x minus under root y minus x. Now this is a plus b, a minus b. A plus b into a minus b is a squared minus b squared. So it will be under root y plus x whole square and under root y minus x whole square. It will be y plus x minus y plus x. So it will be twice of x. So it will be twice of x in the denominator. And a minus b and a minus b. So the numerator will be a minus b whole square. A minus b whole square is a square plus b square minus 2ab. A square is, you can just remove the root. So y plus x plus y minus x minus twice of under root. So under root y plus x into y minus x will be a plus b into a minus b will be a square minus b square. So you can have y square under root y square minus x square. So under root y square minus x square. Now here 2x is already there in the denominator. X cancel. Y will be 2y minus twice of y square minus x square divided by 2x. Now you can just cancel this 2 to 2 because it can be taken common. So you have y minus under root y square minus x square divided by 2x. It is x because 2 has been cancelled. So how can we write? It is y by x minus. Now I am taking this x in the denominator, so it has to be x square. If I want to take in the denominator with an under root, x will be under root x square. It is actually equal to x only. So how can we write this? This is y by x already minus, now this x square can again be taken in the denominator for both the terms in the numerator. So we have y square by x square minus x square by x square. So y square by x square minus 1. Y square by x square minus 1. And this is your final result which was expected. This is your answer. Okay, this is all about this exercise. Thank you so much and take care of yourself.